Okay, this is the final section of the um, chapter, section 14.3, the ear. Very fascinating chapter, especially if you can take the MCAT. It might do you some good to study this. Let's move this off to the side. The human ear is divided into three regions: the outer ear, the middle ear, and the inner ear, as you can see in the figure. The outer ear uh, consists of the ear canal, which is open to the atmosphere, terminating at the eardrum called the tympanum. Sound waves travel down the ear canal to the eardrum, which vibrates in and out of phase, in and out in phase with the pushes and pulls caused by the alternating high and low pressures of the waves, the compressions and the rarefactions. Behind the eardrum are three small bones of the middle ear, called the hammer, the anvil, and the stirrup because of their shapes. These bones transmit the vibration to the inner ear, which contains the cochlea, a snail-like shaped tube about 2 centimeters long. The cochlea makes contact with the stirrup at the oval window and is divided along its length by the basilar membrane, which consists of small hairs, cilia, and nerve fibers. This membrane varies in mass per unit length and in tension along its length, and different portions of it resonate at different frequencies. Along the basilar membrane are numerous nerve endings which sense the vibration of the membrane and in turn transmit impulses to the brain. The brain interprets the impulses as sounds of varying frequency, depending on the locations along the basilar membrane of the impulse transmitting nerves and on the rates at which the impulses are transmitted. Okay. This figure shows the frequency response curves of an average human ear for sounds of equal loudness, ranging from 0 to 120 dB. We can think of the bottom curve as the threshold of hearing. Let's take a look at the intensity level on the vertical axis for the two frequencies, 100 hertz and 1000 hertz. The vertical axis shows that the 100 hertz sound must be about 38 dB greater than the 1000 hertz sound to be at the threshold of hearing, which means that the threshold of hearing is very strongly dependent on the frequency. The easiest frequencies to hear are around 3,300 hertz, and those above 12,000 hertz or below about 50 hertz must be relatively intense to be heard. Notice that the curves flatten out as the intensity levels of the sound increase. So when sounds are loud, all frequencies can be heard equally well. Let's get back, let's look at the ear again. The small bones in the middle ear represent an intricate lever system that increases the force on the oval window. The pressure is greatly magnified because the surface area of the eardrum is about 20 times that of the oval window. We can compare this to a hydraulic press. The middle ear, together with the eardrum and oval window, in effect acts as a matching network between the air in the outer ear and the liquid in the inner ear. The overall energy transfer between the outer ear and the inner ear is very efficient, with pressure amplification factors of several thousand. In other words, pressure variations in the inner ear are much greater than those in the outer ear. The ear has its own built-in protection against loud sounds. The muscles connecting the three middle ear bones to the walls control the volume of the sound by changing the tension on the bones as sound builds up, which hinders their ability to transmit vibrations. Also, the eardrum becomes stiffer as the sound intensity increases. These two events make the ear less sensitive to loud incoming sounds. Of course, there's a time delay between the onset of a loud sound and the ear's protective reaction, so a very sudden loud sound can still damage the ear. The complex structure of the human ear is believed to be related to the fact that mammals evolved from seagoing creatures. Insects' ears are considerably simpler in design because insects have always been land residents. A typical insect ear consists of an eardrum exposed directly to the air on one side and to an air-filled cavity on the other side. Nerve cells communicate directly with the cavity in the brain without the need for the complex intermediary of an inner and middle ear. This simple design allows the ear to be placed virtually anywhere on the body, For example, a grasshopper has its ears on its legs. One advantage of the simple insect ear is that the distance and orientation of the ears can be varied so that it is easier to locate sources of sound, such as other insects. One of the most amazing medical advances in recent decades is the cochlear implant, allowing the deaf to hear. Deafness can occur when the hair-like sensors, the cilia and the cochlea, break off over a lifetime, and sometimes because of prolonged exposure to loud sounds. Because the cilia don't grow back, the air loses sensitivity to certain frequencies of sound. The cochlear implant stimulates the nerves in the ear electronically to restore hearing loss that is due to damaged or absent cilia. And that concludes the lectures for chapter 14. I hope it has served you well. Stop sharing.